Hi, my name is Arkush. I'm a principal solutions engineer at Akamai. And today I will take you to a journey about API security. We'll start by explaining the basics, how modern API-based applications are more vulnerable and the risk factors associated with them compared to traditional apps. Then we'll share real-world data on API attacks, trends, and statistics. Then we will analyze a couple of API attacks, and we will finish talking about mitigations and best practices. Ready? Let's go. So let's take a very simplified scenario of a user launching a browser and then logging into an application and going to the dashboard to see the news, the notifications, and updates. So we have a request going from the client browser to get the dashboard ASPX file. Then the web server sends a query to the database to fetch the data. It can be an SQL query, for example. Then the data comes back to the web server. The web server formats the HTML, filters out any unneeded data, and then sends the HTML in one response back to the web browser. With APIs, it's a little bit different. Let's say the user is using his mobile application. So the mobile application on the client side takes care of all the formatting and everything like that. So we only need the raw data. Instead of one HTTP request, now we have 3 requests going to 3 different API endpoints to get the messages, notifications, and news. The web server gets the 3 requests, then fetches the data from the database. It can be in very similar way to the traditional app, but then it doesn't do the formatting or filtering of any excessive data. It just sends the raw data back to the client, assuming the client mobile application will know how to filter unneeded data or PII information or anything like that and present only what the user is supposed to see. So what we can deduct here that APIs are oversharing. They are easier to guess and to interact with. You don't need to log in or anything like that. The attacker can just send requests, gets, posts, and get data. And the developers are not thinking about what attackers might do with all the response in the data in the response JSON body, but what the application, the mobile application will do or supposed to do. And that's what makes it API-based applications more vulnerable and oversharing data that attackers might be using. I work at Akamai, and we serve and deliver between 15 and 30% of the internet data every day. So a decade ago, we started creating and sharing these SOTI reports, State of the Internet report, showing data about trends and different security attacks that we see all over the place. And sometimes we do specific reports for a specific vertical, like financial services. And sometimes we do on a specific attack vector, like APIs. So I'm going to show you a few statistics on API attacks. So this first one is showing the distribution between web-based attacks and API-targeted attacks in different sectors. And you can see the commerce sector is at the top of the list. Almost 50% of the attacks are API-based. And it can be attributed to the fact that the adoption of mobile apps and API-based applications are more higher in the commerce space, and also the monetary value that attackers might gain from doing account takeover and credential stuffing and getting some financial monetary value from merchandise might be higher than other sectors. This one is based on region. So here we can see that surprisingly in Europe, Middle East and Africa, EMEA, the ratio of API-focused attacks is the highest. We would expect that Latin America and Asia Pacific would be at the bottom of the list, but to see Europe significantly higher than North America is a little bit surprising. And it can be attributed to both the adoption of different compliance standards like PSD2 and GDPR. Also, the two wars in Europe might contribute to attackers that are hacktivists or activists and want to take down, API-based government websites, for example. But for sure, if you are in commerce in Europe, then your APIs are a juicy target, for sure. And this quote is from Chris Eng. He's a chief research officer in Veracode. He helped us with one of the SOTI or State of the Internet report. And Chris has decades of experience in security. And he's saying we're making all the same mistakes with API security that we made with web security 20 years ago. And the meaning is that, again, as developers are thinking how to develop the next feature in the next sprint, they don't really have a security mindset, or they're not thinking how the attacker might leverage this business logic flaw or this excessive data that is shared, but they are trusting the next service that requests the data from their service to handle it properly. And we're making the same mistakes that we did 20 years ago, not thinking and having security as an oversight after the application is developed. And in fact, I saw a statistic about like 46% of organizations admit they release vulnerable code into production because they know they cannot handle or close all the vulnerabilities with APIs. So let's shift gears and talk about common API attack vectors. So we have DDoS, distributed denial of service, injection attacks, web application attacks, and business logic abuse, which are more trickier. So we start with DDoS. DDoS is distributed denial of service. As we said, Europe is as high as North America. It might be attributed to the two wars that are going on in Europe and hacktivists that are trying to take down government or public sector-based websites. And in general, DDoS, or availability, the opposite of distributed denial of service, signifies trust. All right, if we go to the website, like a CIA website, and we see that it's down or it responds with an error, it doesn't matter if it was only like a poster showing like public facing statistics on the CIA. It signals that the trust of the brand is impacted with this downtime. So that's why DDoS attacks that can be targeted to websites and also can be targeted to API endpoints. Like, for example, if I'm going to the airport, I want to take a train, I open my Google Maps and I look at the train schedule, and suddenly I cannot see the schedule because Google Maps are sending API requests to the train company, and someone is attacking the train company's API endpoint that Google uses, so they cannot present the schedule, and I, as a consumer, is impacted by this downtime. Application-based attacks or injection-based attacks are always out there and can be used against websites or web applications and API-based applications. So in this graph, look at it like a clock. It's 15 months of data. In each segment is 3 months, and you can see each color is a different type of web application attack. So the light blue or turquoise is cross-site scripting. You can see it's always there. It's pretty high. The injection, SQL injection, is dark blue, and it's start low and increases a bit. And you can see the orange really picking up in the last 6 months of this graph. It's a local file inclusion, and it's attributed to ransomware. And the gist of it is that web application attacks can also target API-based endpoints or services or applications, and you should, use some security control like web application firewall to mitigate them. And the third attack vector of APIs are more tricky. It's business logic abuse. It means that someone will go and authenticate as a user and then change some parameter or change the user ID or the account ID and get data that it's not supposed to get, and by that might do account takeover and scrape data and do data breaches. So in this example, we saw a loyalty program of one of our customers, and we saw the same user or the same device going to multiple loyalty accounts and get the loyalty award. Within 24 hours, we detected fraudulent activities of around $100,000. And the tell was that allowed us to detect this attack was that the same loyalty award was seen across multiple accounts, right? The attacker used the same loyalty award and scraped them from multiple accounts and then transferred them or sold them to other accounts illegally. And the same can be done in, and this is one of the famous, ride-sharing company or ride-sharing application. It was published in the media, and you can read some blog posts about it. And in this one, the attacker was using two API endpoints. The first one is trying to add a driver based on the phone number or an email address. And phone numbers and email address can be easily scraped from social media or by doing some social engineering. And if the driver's phone number was in the database of this ride-sharing company, there was an error message coming back in the response with the driver's user ID, unique user ID. So the second part of the attack was using another endpoint, posting this user ID that was returned by the first API endpoint, and the post to get consent screen details with the driver's user ID, and the response contained a lot of personal identified information, PII, and the access token of this driver, not the attacker's access token, but the driver's access token, which allowed the attacker to take over the driver's account, the victim's account. All right, so here you can see the first request with the phone number and the error message with the driver's UUID, unique user ID. And then the second request with the UUID, and then all this PII information and access token was returned. So what happened here? So there are two API-based vulnerabilities that were leveraged here. The first one is excessive data exposure, right? The error message should not have contained the driver's UUID. And this is called broken object property level authorization. Basically, a property was returned that was not supposed to be returned. Like a credit card, for example, with trying to do a transaction, and the response contains the credit card details of the user. The second part was the BOLA, or broken object level authorization, and this means that one user, an attacker, can gain access or do some operations to other users' accounts. All right, so you can see here there is the first username is the attacker's username, and then the second request is the victim username, and the data is being returned as well. And these attacks are based on the relationship that usually, like in financial services applications, you have user ID and you have account ID, and there is one-to-one relationship. And you need to develop a baseline of the behavior of most normal users. And then you can see a deviation or anomaly, like one user ID 777 is accessing multiple accounts. That it's a very abnormal behavior that should be detected and handled. So this one is a nice quote I thought sharing with you. Attackers don't break in, they log in. And this means that they don't need to, most of the vulnerabilities are related to authentication and authorization. And these are the OWASP API top 10, Open Web Application Security Project, OWASP. and they released in 2023 a list of the 10 most popular vulnerabilities of APIs. And you can see the top 5, like 4 out of the top 5 are related to authentication and authorization issues. And attackers know it, and they log in, and then they change some parameter and gain access to other users' accounts using the access token of the victims or their user IDs, like we saw before. So we'll talk now in the last few minutes about mitigation and best practices, how to handle these kind of attacks and vulnerabilities. So the goal is to have quality code in production. So first, in the software development lifecycle, you need to test the code, detect common security and posture issues. And posture issues can be using basic authentication instead of OAuth, which is more secure, passing sensitive data in the URL or the query parameters instead of headers and request body, which is, again, more secure, and not applying rate limiting, which might cause DDoS attacks, distributed denial of service attacks, and so on. And then after you release the code and deploy it to production, then you need to detect all of your APIs, including zombie or legacy APIs that you forgot that are exposed to the internet because you moved on to newer versions, but they are still out there. Classify all the data labels, meaning know which API endpoints are exposing PII information and label them, and then triage critical issues that are detected and give feedback to other security controls like web application firewall or API gateway to block these API abuse attempts. So what kind of mitigation are we talking about? If we're talking about DDoS attacks, then you should apply rate limiting and have cloud-based DDoS mitigation solutions. Any web application or injection attacks that we talked about, use a web application firewall and make sure you have the latest version, and also make sure to have it in block mode, not only in monitor mode. A lot of customers are deploying the WAF, but keeping it in monitor mode, which is not effective and not blocking anything. Bot attacks can be, you can block known botnets like Mirai botnet, for example, and also build in a bot management solution in your application. Regarding the business logic abuse, then you'll need to do some behavioral analysis, establish this baseline of normal behavior, and then detect all the anomalies and have some kind of platform to analyze them. So this is the API security maturity level, starting from shining a light on all of your API, shadow APIs, right? To have a list of all your API services, all your endpoint, label all the PII data, get organized, make sure you group them by service, by PII data, by version, and so on. Then harden your API posture, meaning close all the vulnerabilities that you found early in the software development lifecycle, and make sure you have the highest posture when you release code to production. Then you should have some kind of practice in terms of threat detection and response, meaning you detected some kind of API abuse. Who do you pick up the phone? Who is on call? What do they do? How do they mitigate it? And the fifth level, or the highest mature organizations, develop a proactive approach. They do API testing early in the software development lifecycle. They shift left. They also proactively look for any kind of anomalies and detect any kind of API abuse, and then make sure they test the business logic and think like attackers when they develop new features and release new code to production. So the key takeaways are APIs are a primary target, ensure sufficient protections against DDoS, against injection attacks, and against business logic abuse attacks, and ensure you know all of your APIs, where are they located, and what kind of data they are exposing. So thank you very much. I appreciate your time and hope you enjoyed this session. Thank you.